Good morning. Today we're going to talk about identifying angles. We're going to see the definitions, how to create them, and what they look like. Alright, so let's jump into it. Angle. It's when two rays that share an endpoint. Remember, two rays. What are rays? They start at a dot and they go on forever in one direction. Now here's one ray. We have two rays that share an endpoint. So here's the endpoint. There's one ray. And if I draw another line, ray, going out, I have two rays. One right here, the other one right here. And they share an endpoint. What we have now is called an angle. Okay? And you've seen these before. Vertex. Point where two segments, lines, or rays meet to form an angle. If you want to think of it as a corner, you can. Okay? It's wherever two segments, lines, or rays meet. Now, most of the time, it'll just be the rays that meet. So looking over here at our example, where is the vertex? Right there. Okay, that's a vertex. That's where the two rays meet. It's our little corner. Looking at the acute angle, where's my corner or vertex? Right here. Where's my corner or vertex? Right here. Here. And is there a corner on this one? No, not really. It's just a straight line. Okay? Now, if there is dots that represent it, it's a dot in the middle, so it should be around here. That would be the vertex. You can't see it right now because it doesn't look like it has an angle. But if there's three dots, like this would be the vertex. Alright, now let's go over the different types of angles. So the first one is acute angle. An angle with a measure greater than 0 but less than 90. Okay? So, I always like to think of it as acute is acute angle. And when we think of something that's cute, think of something that's small. Okay? You want to think of this as a small angle. Acute angle. So it's going to be a small one. So anything that is greater than 0 but less than 90. Okay. So if I choose something like this, or maybe this, maybe like that. These are all acute angles. The angles are very small. Okay? And we'll go over it a little more in detail. Obtuse angle. An angle with a measure greater than 90 but less than 180. So obtuse, you want to think of as big. This is your big angle. Okay? And we have measures that look like this, maybe even more spread out. So we're measuring this angle right here. You can see it's very big. Okay? And whenever you see something that looks like this, where it's spread out, that's obtuse angle. The next one is your right angle. Okay? There's something special about right angles. It's an angle that measures with equal to 90. It has to be exactly equal to 90. And what does a 90-degree angle look like? Right here. Okay? You know it's a right angle if it has that little square. We kind of went over this before. But this little box at the vertex will always tell you 90 degrees. Okay? Another way to remember it is it looks like the letter L. Okay? If you hold up your thumb and index finger making the L, that would be a right angle. Or if you use a piece of paper, any piece of paper, those corners, those are right angles as well. So I'm going to show you what I mean. I'm going to draw a little piece of paper, let's say. All right. Each corner has a right angle. So this is a right angled measurement. Now if I take my piece of paper and put it at the vertex, you can see if this is 90, this is less than 90. If I go all the way, that's 90, but I'm only going a small amount. So this is acute. If I bring it over to this vertex corner, I can see the angle is wider than 90. It's bigger, it goes past the corner. Okay? So that's obtuse. If I bring it to the right angle, you see how it measures perfectly? So right angle is right angle. 90 degrees, 90 degrees. Okay. And the last one is straight angle. An angle with a measure equal to 180, or a straight line. That is probably the easiest thing to remember. Straight line. So a straight angle is pretty much a straight line. So to review, angle has two rays that share an endpoint. Look over here. These are two rays, and they're sharing their beginning, like a ray of sun. Vertex, points where two segments, lines, or rays meet to form an angle. I want you to think of it as a corner. So over here, here would be my vertex, here would be my vertex, here will be my vertex. Okay? Always think of it as a corner where two rays meet. Acute angle, it's a small angle greater than 0 but less than 90. Remember, acute angle. It's small. So if it's smaller than 90, it's an acute angle. Obtuse angle. It's greater than 90 but less than 180. This is what we want to think of it as the big angle. It is going beyond 90 degrees. If I took my piece of paper, put it at the corner, lined it up, we can see that angle goes beyond 90 degrees, thus being obtuse. Same thing over here, same thing over here. Right angle, it's an angle measure equal to 90. Okay? Right angles are equal to 90 degrees, and they look like the L, or a corner of a piece of paper. Right angle. And straight angle is an angle with a measure equal to 180. So remember, think of a straight line. Straight angle, straight line. An angle is named by its vertex, or with its endpoints first. Okay? The vertex in the middle, and the other endpoint last. So you want to think of it as endpoint, vertex, endpoint. Or the outside, inside, outside. Okay? So let me try this out. Let's draw an angle like this. If I wrote the letters A, B, C, what would I call this angle? So I'm going to use my endpoints right here, right here. So let's go alphabetically. I have my endpoint here, A. So A, and I'm going to continue, continue, continue. B, which is my vertex, and C, which is my other endpoint. So we can call this angle ABC. Now what if you started at the bottom? Could we do C, B, A? Yeah, we could. All it says is endpoint first, vertex in the middle, endpoint last. I'm starting at my endpoint C, going to my vertex B, and then going to A. So this is ABC or CBA. Either way works. Now, if I look at this angle, is it acute, obtuse, right, or straight? So I'm going to grab my piece of paper, bring it over, line it up with the vertex in the corner, and line it up with one of the lines. And we see that if I measure from here to here, this is a small angle. It's less than 90. So this would be an acute angle. All right, let me make another one. And let's call this T, Z, X. How would I write this? Remember, starting from one point, end point, and just writing it through. So this would be angle T, Z, X, or X, Z, T. Now let me grab my piece of paper. Let's figure out if this is acute, obtuse, right, or straight. All right. So if I move that piece of paper, I found out, I could put it in the corner, but it's not lined up perfectly. So I'm going to rotate this one to measure it. Let's see if this works. All right. And here, pretty much perfect. Okay. It's lined up at the corner and it's lined up on one of the rays. This is a right angle. And if I am to draw this angle, I see it's bigger than 90 degrees. And which one is greater than 90 degrees? Look here, obtuse angle. You see it's a nice long, wide angle. It's past 90, so this would be obtuse. Okay, I'm going to review the homework just very quickly. Identify each angle as acute, obtuse, right, or straight. Look at the numbers. This will tell you where it falls between 0 and 90, 90 and 90 and 180. Go back and look at the top page, and I want you to look at this. Figure out where it belongs. Okay? Identify each diagram as acute, obtuse, right, or straight. Now we have the pictures. Remember, acute is your small one, obtuse is your big one, right angle is 90 degrees, and straight is a straight line. So when you look at this, is it acute, obtuse, right, or straight? Do it throughout. The last part is draw and label each of the following. An acute angle, HIJ, obtuse angle, DEF, and right angle, GHI. So when you be drawing, acute, obtuse, right, and don't forget to label it. Okay? There are other activities I want you to try out. Today's a busy day.